Hi students, welcome back to next part of electrochemistry. So see here, so electrochemistry, that is part 12. Electrochemistry part 12. So in the last class I explained about Faraday's laws. So electrolysis of Faraday's laws. There are two Faraday's laws are there. Faraday's first law and Faraday's second law. Faraday's first law, the amount of substance liberated or deposited is directly proportional to quantity of electricity passed through the electrolyte. Quantity of electricity passed through the electrolyte. See here, Faraday's first law. Just we are revising this concept. Next we go to next concept. So Faraday's first law. Faraday's first law. In the last class, what we did? So amount of substance liberated or deposited is directly proportional to quantity of electricity passed. So from this, we can obtain that W is equal to J into Q. J into Q. So what is the J here? J is equal to E by F. E by F. J is equal to E by F. Electrovalence by Faraday's. Faraday means 96,500 coulombs. So what is E here? E is equal to capital M by E is equal to capital M by N factor. Capital M by N factor. So what is N factor? Number of electrons transferred. Number of electrons transferred. Or number of electrons required to convert reactants to products. And M is atomic weight. Atomic weight. So Z is equal to, if you substitute here M by N into F. So Z value will become as like this. Z value will become as like this. So if you substitute this Z value here we will get W is equal to M by NF into Q. NF into Q. So after that, what is Q? Q is equal to I into T. Q is equal to I into. So W is equal to M by NF into I into T. So this is the final formula we have taken or we have derived from the Faraday's first law. Faraday's first law. So here Faraday's first law means the amount of substance deposited or liberated is directly proportional to quantity of electricity passed through the electrolyte. That is Q. That is the Q. So W is equal to, by removing this proportionality, we are putting a constant that is called electrochemical equivalent. Electrochemical equivalent. So W is equal to Z into Q. Z is equal to E by F and E is equal to M by N factor. Z is equal to M by NF. So W is equal to M by NF into Q. So W is equal to M by NF into IT and Q is equal to IT because Q is equal to IT. Q is equal to IT. So from the first law, we have derived this one. We have derived this equation. Next, when we go to second law, Faraday's second law. So what is Faraday's second law? What is Faraday's second law? So the amount of substance, here we have taken three beakers and same quantity of electricity is passed through the electrolytes. Same quantity of electricity is passed through the electrolyte solution. Same quantity of electricity is passed through the electrolyte solution. Then the mass deposited or liberated, the mass of substance or amount of substance deposited or liberated, amount of substance deposited or liberated is directly proportional to their respective equivalent weights. Their respective equivalent. So if you are taking A, B and C, here we are taking a beakers and a solution we are taking like this. So in this taking electrodes, look at here, we are taking electrodes like this. here we calculate resistance like this. So if you pass same quantity of current electricity here, same quantity of current, so what will happen here? Amount of substance liberated M1 is directly proportional to E1. They equivalent weights. Like this, M2 is directly proportional to E2, not capital, small M1, small M2. Next, M3 is directly proportional to E3. M3 is directly proportional to E3. So here, what you have to understand is when same quantity of current is passed to the electrolytes, same quantity of current is passed to the electrolyte, the amount of substance liberated or deposited is directly proportional to their respective equivalent weights. Their respective equivalent. That means here equivalent weight is E1 for A and is B1 for B, E2 for B and E3 for C. So M1 is not directly proportional to E2. M1 is proportional to only E1 and M2 is proportional to only E2. So like that, M1 proportional to E1, M2 proportional to E2, M3 proportional to E3. So finally we will get M1 is to M2 is to M3 is equal to E1 is to E2 is to E3. E2 is to E3. So we will get this expression by Faraday's second law. Faraday's second law. Simple here. The amount of substance liberated or deposited is directly proportional to their respective equivalent weights. That is Faraday's second law. This Faraday's second law. So Faraday's first law and second law completed. Next, so we are going to study the standard SRP values. SRP means standard reduction potential values. SRP values, standard reduction potential value. So here for this one series is there. So by using that series, we have to remember that series. By using that series, we can calculate which product is formed at cathode, which product is formed at anode on electrolysis. By aqueous solution. So now here, look at here. If you see the series here, the series is written as like this. Lithium plus K plus Ca plus 2, Na plus 1, Mg plus 2, Al plus 3, H2O, reduction. Next, Zn plus 2, Cr plus 3, Fe plus 2, CO plus 2, Ni plus 2, Sn plus 2, Pb plus 2, H plus Cu plus 2, OH minus, Hg2 plus 2, NO3 minus 1, Cl minus 1, H2O, oxidation, SO4 minus 2, F minus. See here. So this is the electrochemical series and the SRP values order. See here. If you take this is first one, this second one, third one, fourth one, fifth, sixth, 7, 8, 9 and 10. So 11, 12, 13, 14, 15, 16, 17, 18, 19 So totally we got 23. So this order we have to remember. Simple. And here this order we have to remember. So simple. What is the use of this order we have to know first of all. What is the use of this order? See, on electrolysis, suppose on electrolysis, look at here. So I am taking NaCl. On electrolysis, what happened here? Na plus Cl minus is formed. Na plus and Cl minus. So what is the deposited at cathode and what is deposited at anode? So this we cannot observe here. We have it right here. This is the series. See, by using this, what is the use? What is the use means on electrolysis. On electrolysis, NaCl on electrolysis, Na plus and Cl minus is formed. So on electrolysis, which is formed at cathode and which is formed at anode. Which is formed at anode, by using this series only we can calculate. By using this series only we can calculate. So this series is very important to remember. See, look at here. See, it is very easy. See, first this having low value. Low value means minus 3.9 or something SRP value is there. So those are having high value. Low value, high value. This is arriving plus 4 something is there, plus 4. Simply remember that we don't by heart the values here. Simply remember this is having low value because it is first. It is having high value because it is high 23. Low, high. Remember like that. And next here, how to remember this series? First here, up to H2O on reduction. H2O reduction is there. Up to H2O, all are first year group elements, second year group elements and third year. Maximum first and second year, next to third year group element is there. Look at here. Lithium plus first year, K plus first year group, Ca plus 2 second year group, Na plus first year group, Mg plus 2 second year, Al plus 3 third year group element. So in this way, first year, second year, third year will come. After that, next all will come. See here. Last F minus will come. F minus F belongs to which one? 7th year group element. F belongs to 7th year group element. Like this, you have to remember the order of this. You just by heart this one. If you by heart this, it becomes very easy. If you practice this, it becomes very easy. See now, what is the use of this order? What is the use of this order? Look at here. This is 11 and this is 21 like this. Here. So you have to remember one more thing here. I will write in the short way this one. It is reduction. Next up, CO plus 2, Na plus 2, Sn plus 2, Pb plus 2, H plus, Cu plus 2, OH minus, H2 plus 2, NO3 minus, Cl minus, H2O oxidation. H2O oxidation. So oxygen is formed. You have to remember like this. Oxidation, what is formed here? Oxygen is formed. Next, SO4 minus 2, F minus. F. This is the order. This is the order. So 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22 and 23. So here is reduction H2O and H2O oxidation. H2O oxidation. So see here next up. See. So which will on electrolysis, the question will ask as I will tell you. The question on electrolysis of NaCl. So Na plus and Cl minus is found generally. Cl minus. If it is fused NaCl, fused means there is no water content is there. There is no water content. Fused means there is no water content. Purely NaCl is there. Na plus and Cl minus is found. So what is found at cathode here in fused? Cathode Na is found and anode Cl is found. How? Say Na cathode Na plus electron gives rise to Na, and the anode Cl minus give Cl2 plus 2 electrons to Cl minus 2 electrons. Understand? 2 electrons because 2 minus 2 minus. So it is formed at cathode and it is formed at anode. It is formed at anode. Okay? So, but if it is fused NaCl, fused means there is no water content. Suppose it is water is added. Water is added. What happened? Aqueous NaCl. If water is added, fused NaCl becomes aqueous because water is added. So in aqueous NaCl, what is formed at cathode and what is formed at anode, that you have to calculate by using this series. By using this series. How means? Look at here. Cathode. So generally cathode. Look at here. Cathode. You remember that cathode generally what happened? Reduction take place. Cathode reduction take place, and SRP value is high. SRP value is high. And anode, this also you have to remember. Anode oxidation take place. Anode generally we know SRP value is low. SRP value is low. So cathode oxidation take place. Cathode reduction take place. Anode oxidation take place. See now when you go to the question is like this. In aqueous NaCl, of electrolysis, aqueous NaCl by electrolysis, what is formed at a cathode? What is formed at a cathode and at a anode? This is the question. See, look at here. At a cathode, aqueous NaCl. Look at here. Aqueous. So here we can write the answer. Aqueous NaCl. NaCl aqueous. NaCl how many splits? NaCl splits as Na plus Cl minus. Na plus Cl minus. Cathode. Look at here. Cathode. So cathode, which will come here? Cathode means reduction. Reduction means what? Reduction means gaining of electrons. So Na plus gains electrons and Na is formed. So what about anode? Oxidation. Cl minus gives rise to Cl2 plus 2 electrons. Cl2 plus 2 electrons. Now here cathode Na plus comes here. Cathode Na plus and anode Cl minus. But it is aqueous. If it is fused means there are no water is there. So directly these products are formed in aqueous. So what he wrote? Cathode. What will come here? Na plus is there. Na plus. And aqueous means what? Water is also there. Aqueous means water is also there. So cathode water is what? Reduction take place. Cathode what is that? Water reduction take place. So among Na plus and H2O reduction, cathode means SRP value is what? SRP value is high. See, look at it. Na plus and H2O reduction. Na plus and H2O reduction. Cathode what is that? SRP value is high. So these are all SRP values. So SRP value is high. So Na plus and H2O reduction, which is having more SRP value? This one. This one is having more SRP value. So here this will not consider. This only will consider because cathode SRP value is more. So H2O on reduction. Look at it. H2O on reduction. What product is found? H2 plus 2OH minus. and here it is 2. So now here which product is formed here? Cathode. H2 gas is formed at the cathode. H2 gas is formed. Like this, we have to calculate the anode also. Anode. See, look at here. Anode Cl minus we have to take. Anode Cl minus. And also H2O. Anode oxidation. Okay. So SRP value is low. Cl minus and H2O oxidation, which is having less SRP value. Cl minus and H2O oxidation. Look at it. This is oxidation. This is reduction. This is oxidation. This is reduction. H2O and Cl minus, which is having less SRP value. This is having less SRP value is low at anode. Anode SRP value is low. That only we have to consider. Cathode SRP value is more. So anode SRP value is low. Cl minus and H2 oxidation, which is having a less SRP value. So Cl minus and H2 oxidation, which is having less SRP value, Cl minus. Among this, which is having less means in reverse order. It is 21 and it is 20. Which is having less, Cl minus is lesser. So Cl minus that is we can consider this one. We cannot consider this one. So here Cl minus gives rise to Cl2 plus 2 electrons. Cl2 plus 2 electrons. So Cl2 is formed. Which is formed here? Cl2 is formed. So here what we understand is in aqueous NaCl by electrolysis, what is formed at cathode and what is formed at anode. So at cathode H2 is formed and anode Cl2 is formed. But generally in fused NaCl by electrolysis, what is formed at cathode and what is formed at anode? Fused means there are no water, only NaCl is there. So cathode Na is formed and anode Cl2 is formed. But here in aqueous, what is formed? H2 is formed at cathode and anode Cl2 is formed. In this way, these questions are very important. In this way, we have to do the problem. Simple here, we have to remember only two things. One is you have to by heart this series, this SRP series. And second one is you have to remember that generally we know cathode reduction takes place and anode oxidation takes place. Here we have to remember cathode SRP value is high. We are taking SRP value is high at cathode and anode SRP value is low. We are taking SRP value is low. So by using this concept, we are doing these problems. We are doing the problems. And take a note, take a screenshot for notes. Next we will do one more problem. This is SRP, standard reaction potential. SRP, standard reaction potential. Next question. Next question. See here. In a aqueous KCl by electrolysis, what product is formed at cathode and what product is formed at anode? What product is formed at anode? See, look at here. KCl, how can it fix KCl? K plus Cl minus. K plus and Cl minus. Cathode. What is that? K plus cathode. And aqueous, here it is aqueous. That means what is also there. So water, cathode means what? Reduction takes place. Water reduction. So here among this both K plus and H2O reduction, SRP value is what? High. So among this, which one is having SRP value is high? That one we will consider. K plus and H2O reduction. Which one is having SRP value is high? Which one is K plus and H2O reduction? Which one is having SRP value is high? This is 2, this is 7. So H2O reduction is having SRP value is high. So this only we consider. That is H2O of reduction H2 plus 2OH minus. This is 2H2O. So which product is formed here? H2 is formed. So at cathode, in aqueous KCl by electrolysis at cathode, H2 is formed. Like that at anode. Anode what is there? Cl minus and H2O. H2O means why you are writing H2O? Because it is aqueous. So H2O anode oxidation. So Cl minus and H2O oxidation, which is having low SRP values. Cl minus and H2O oxidation, which is having low SRP values. Cl minus. Why? Because it is 20. It is 21. So which is having low SRP value? Cl minus. Cl minus converts to Cl2 plus 2 electrons. So it is to balance this, here we can put Cl2. So what is formed here? Cl2 is formed. So now here what is the answers are? In aqueous KCl by electrolysis, what product is formed at cathode and what product is formed at anode is H2 is formed at cathode and Cl2 is formed at anode. So these are the products formed at the anode and cathode. So in this way, if you remember this one, and it is very easy to calculate. This question is very important. So many times in a NEET and in AIMS also asked these questions. So for objective pattern, these are very important. So the question will ask as simply here, see here, the question will need objective pattern, how it will ask as the following product formed at anode on electrolysis of aqueous KCl. See options 1 H2, option 2 Cl2, option 3 Na, option 4 H2O. So you look at here, the question is like this: the following product formed at the anode on electrolysis of aqueous KCl. The following product formed at the anode on electrolysis of aqueous KCl. So options are H2, Cl2, Na and Cl, Na and H2O. On the following electrolysis of aqueous KCl, aqueous KCl on electrolysis at the anode, which product is formed? Anode, which product is formed here? Cl2 is formed. So option is second one, Cl2. It is correct one. Cl2 is correct one. So in this way, they will ask you the questions. Next, we'll do the next one. Next one, in aqueous K2SO4, by electrolysis, what product is formed at cathode and what product is formed at anode? K2SO4, how many splits are K plus SO4 minus 2, 2K plus SO4 minus 2. So we don't want any moles here. Moles are not required. Simply which cation is formed, which anion is formed. That is enough. So now when you go to cathode, look at here. Cathode which will take here K plus and H2O reduction. H2O reduction. So among this SRP values, cathode what? SRP value is more. So among this, which one is having more SRP value? K plus and H2O reduction. Which one is having more SRP value? It is 2, it is 7. Which one is more? H2O reduction is more. So this one we will consider. So now H2O reduction, what will happen here? What product is from H2 plus 2OH minus. H2 plus 2OH minus. So now this is if you balance the moles here, 2H2. So now which is formed at H2 is formed. Which is formed at cathode? H2 is formed. So like that H2 is formed. So K plus H2 reduction, which is having high value, SRP value is high at cathode. So only we are taking H2 reduction. Next like that when you go to anode, SO4 minus 2 and H2O oxidation. So anode SRP value is low. So among SO4 minus 2 and H2O oxidation, which is having less SRP value? See here, H2O reduction oxidation and SO4 minus 2, which is having less SRP value. H2O oxidation having 21, SO4 minus 2 is having 22, which is having less H2O oxidation. So this one we will consider. This is having less SRP value. So H2O oxidation, what is from here? O2 plus 2H plus. So O2 is formed. That means here. So this is totally different are formed. In aqueous K2SO4, then generally in fused K2SO4, what is formed? K plus and SO4 minus 2. Fused. But in aqueous, what is formed in cathode? Cathode H2 is formed and at anode O2 is formed. Totally different are formed. Like this, by using this SRP values, we can calculate by using this SRP values order and also this one, we can calculate which product is formed at cathode and which product is formed at anode by electrolysis. So take a screenshot for notes. Next, in aqueous H2SO4, H2SO4. So by electrolysis, in aqueous H2SO4, by electrolysis, what product is formed at cathode and what product is formed at anode? See here, cathode. So generally H2SO4, how can it splits, sir? Generally H2SO4 splits as 2H plus and SO4 minus 2. SO4 minus 2. So first if you take cathode H plus and H2O reduction, H2O reduction, H plus and H2O reduction. So like that anode SO4 minus 2 H2O oxidation. So H plus and H2O reduction, among this which is having a highest RP value? Which is having highest RP value only we consider it a cathode. H plus and H2O reduction, which is having a highest RP value. Look at here, H plus is here and H2O reduction is having here. Which one is having highest RP value? H plus is having highest RP value. So if this one will consider H plus, 2H plus, use H2 gas. So H2 is formed here, cathode. H2 is formed at cathode. Simply you can write here like this, H2. Next, SO4 minus 2 and H2 oxidation. Which one is having the lowest RP value? SO4 minus 2 and H2 oxidation. Which one is having lowest RP value? H2O oxidation is having lowest RP value. So this one will consider here. H2O oxidation usage to half O2 plus 2OH minus. So this product is formed. That means what is the final product? O2 is formed. O2 is formed. The same question like that they will ask you. You need the following product formed at anode and cathode on electrolysis of aqueous H2SO4. Anode, what is formed here? O2 is formed. Aqueous H2SO4, O2 is formed. Next term. Next, aqueous CuCl2. Which product is formed at cathode and which product is formed at anode? CuCl2. How can I split CuCl2? Cu plus 2Cl minus. Cu plus 2Cl minus. And cathode will take Cu plus and H2O reduction. And at anode Cu plus, why? Because positive ion at cathode and because here reduction takes place. and H2O reduction. H2O reduction. Next anode Cl minus and H2O oxidation. H2O oxidation. So if you come to cathode here, cathode SRP value is more. SRP value is more. So among Cu plus and H2O reduction, which is having more SRP value? Cu plus. Where is Cu plus? Cu plus 2. Here Cu plus 2 is there. Cu plus 2. Cu plus 2 and H2O reduction. Which is having more SRP value? Cu plus 2. Cu plus 2. So it is having more SRP value. So only Cu plus 2 plus 2 electrons gives rise to Cu. Cu plus 2 electrons gives rise to Cu. So what product is formed here? Copper is formed at a cathode. So like that Cl minus and Cu plus 2 will consider here. Cl minus and H2O oxidation, which is having the low SRP value. Cl minus and H2O oxidation, which is having low SRP value? Cl minus. SRP value Cl minus. Why? Because Cl minus is 20 and H2O oxidation is 21. So Cl minus will take out. Cl minus gives rise to Cl2 plus 2 electrons. So what is formed here? Cl2 is formed. Finally Cl2 product is formed. That means here in aqueous CuCl2 by electrolysis, Cu is formed at the cathode and the Cl2 is formed at the anode. Cl2 is formed at anode. Take a screenshot. Next CuSO4. CuSO4. Look at here. CuSO4. CuSO4. How can it split? Cu plus 2 plus SO4 minus 2. SO4 minus 2. Cu plus 2 SO4 minus 2. So now here look at here. Cathode and anode. Cathode. So what will take cathode? Cu plus 2 and H2O. What is the H2O reduction? See, look at here. H2O reduction, cathode reduction. So among this one, among Cu plus 2 and H2O reduction, which is having more SRP values? Cu plus 2, H2O reduction, which is having more SRP value. H2O reduction is having 7. This number is 7, and Cu plus 2 number is 16. Cu plus 2 number is 16. So which is more? Cu plus 2 is more. So we can consider this one. Cu plus 2 gives rise to Cu plus 2. You know, reduction take place. Cu plus 2 plus 2 electrons gives rise to Cu. Cu plus 2 plus 2 electrons gives rise to Cu. So which product is formed here? Cu is formed. Which product is formed? Cu is formed. Like that anode. Anode, what is formed is SO4 minus 2 and H2O oxidation. H2O oxidation. Why? Because anode oxidation takes place. Only H2O oxidation. So SRP value is low. Anode SRP value is low. SRP value is low. So among this SO4 minus 2 and H2O oxidation, which is having low SRP value, H2O oxidation and SO4 minus 2, which is having low SRP value, H2O oxidation. Why? Because H2O oxidation is number is 21 and SO4 minus 2 number is 22. So 21 we have to consider because the low value according to anode low value. So H2O oxidation. H2O oxidation will take reduce the H2O of O2 plus 2O minus. So what product is found here? O2 is found. O2 is found. O2 is found. So finally, this electrolysis products on electrolysis of aqueous salts, what products are formed at cathode and what products are formed at anode? These questions are very, very important. So simple, we have to do only one thing. You have to remember this SRP value series, and also this cathode. This you don't want to remember because cathode we know already reduction takes place. Cathode reduction. So here reduction means what? Gaining of electrons. Gaining of electrons means already it is gained. That means SRP value is more. Anode oxidation is losing of electrons. Electrons is losing, so SRP value is low. SRP value is low. So here we have to remember this one. So this is very, very important for objective pattern, for objective and also for PU board also. So many definitely question will come from this concept. Definitely question will come in NEET and also in AIMS. So you have to remember this series. You have to by heart this series, and also this one you don't have to by heart. That is very easy. So this is about electrolysis of salts of aqueous solutions, the products that formed at cathode and next class. So up to here only the syllabus is there. So up to itself electrochemistry is finished. Next we will start the new chapter.